In this video, we're going to go over the slides from this morning's live CC. So before we get started, I want to clarify some topics from 2.06. There are two different types of functions. There are discrete functions and there are continuous functions. Discrete functions, when we graph them, they look like dots. That is because only specific values are included in a discrete function. So we describe the domain and range using lists. Continuous functions are all connected, and they'll include a whole entire set of values. That is why the domain and range are described as inequalities. So when we work on these problems that have word problems, we need to think about some questions to help us guide in solving these problems. So when we look at this, it says the first 8 seconds of an extreme ride at an amusement park, the function h of s equals 4s plus 6 gives the height of a rider in meters above the ground. What is the domain and range? So let's think about this problem. We have this function h of s equals 4s plus 6. So if we look at the input, the independent variable is going to be s, which is the seconds. The output variable, which is h, will be the height. So now we need to think about if it's discrete or continuous. So the way we figure it out is, does it make sense to have fractions or decimals for the input and output variables? So if we think about seconds, can you have 4.5 seconds? Can you have 5.5 seconds? Yeah, you can. Okay. And then what about height? Can we have 3.5 feet or 7.5 feet? We can also have halves there, right? So since we can have fractions and decimals, it's going to be continuous. So that means that we are going to represent these with inequalities. Okay, so that's why we go through and ask all these questions. We want to know if we need inequalities or if we need lists. So since we need inequalities, let's work on writing out the domain and range. The domain, since it's the input, is going to be s. The range, since it's the output, is going to be h. So the domain talks about the first 8 seconds, so it's going to be 0, less than or equal to s, less than or equal to 8. H, which is the output, is going to be the values that we have at these two endpoints. So to figure it out, we're going to take h of 0, we're going to plug into our function and get 4 times 0 plus 6. So that is 0 plus 6, which equals 6. So we have 6 less than or equal to h, and then we're going to plug in h of 8. So we get 4 times 8 plus 6, which is 32 plus 6, which equals 38. So that is less than or equal to 38. So those are my values of the domain and range. So in the next problem, it says Denise spends $3 per book on every book she buys at the local book sale. She plans to buy no more than 5 books. The cost of buying books C can be modeled by the function C of B equals 3B. What is the domain and range? So we have this function C of B equals 3B. The input, the independent variable, is B, which is the books. The output, which is the dependent variable, is the cost. So is this discrete or continuous? Well, if we think about books, you can't really go by half a book or a fourth of a book, right? You can't really have fractions or decimals. Although cost is money and money is continuous, it's going to be discrete because as long as one of your variables is discrete, you're going to need a list, okay? Both of them have to be continuous for it to be continuous. If one of them is discrete, you're going to need to use lists. So now we have lists for the domain and range, so let's list out the values. So she plans to buy no more than 5 books. So that means that she can buy no books, or 1, 2, 3, 4, or 5. Because domain is going to be B. Range is going to be C, which is the output, and to figure it out, we're going to need to plug into our function. So we have our values of B, which are 0, 1, 2, 3, 4, and 5. Then we plug into C of B for each value, and then we're going to figure out the values of the range. So we have 3 times 0, which is 0. 3 times 1, which is 3. 3 times 2, which is 6. 3 times 3, which is 9. 3 times 4, which is 12. 3 times 5, which is 15. So the range will give us 0, 3, 6, 9, 12, and 15. So if at least one variable is discrete, then you must use lists to describe domain and range. If both variables are continuous, then you use inequalities to describe the domain and range. So things that we use lists for are people, objects. So some examples you all gave were like cupcakes, cookies, pizzas, because those are only things that we can buy in whole numbers, right? If we're buying them at the store, it's going to be an entire cupcake or an entire cookie. Continuous variables are things like time or money, where we can use fractions or decimals. So let's look at these situations and identify whether they're discrete or continuous. So you may want to pause the videos and try these for yourself before I give you the answer. So in question 1, where your mom is printing photos, it's going to be discrete, and we're going to use lists. In this question 2, where Anna's jogging for exercise, it's going to be continuous because we're talking about time and distance. So actually distance is another one we can add to our list. Distance will be continuous because you can have like half a mile or a quarter of a mile and things like that. So since it's continuous, we're going to use inequalities. In question 3, Juliet's selling magazine subscriptions, which will be discrete because you can't sell half a subscription, and we're going to use a list. So in this practice problem, it says the total cost in dollars to buy uniforms on the volleyball team can be found using the function C equals 34.95U plus 6.25, where U is the number of uniforms bought. If there are at least 8 players but not more than 12, what is the domain of the function for this situation? So if we look at this, we have C equals 34.95U plus 6.25. It's only asking us for the domain, which remember is Dixie in our mnemonic, which is the input values. So if we look at this function, the input values are U, which is the number of uniforms. So uniforms, the question now, is it discrete or continuous? Well, you can't buy a partial uniform, right? So you're buying uniforms for people, so you have to use whole numbers. So that is why this will be discrete, and we need to list the values. So we can cross out A and B. So now we need to think about the domain. Well, it says there's at least 8 players, but not more than 12. So that means that our values will be 8, 9, 10, 11, and 12. That is why C is the correct answer. D is not the correct answer because D is actually the range of this function. So in this problem, it says the daily cost of hiring a plumber Y to work X hours on a repair project can be modeled using a linear function. He charges a fixed cost of $80 plus an additional $45 per hour. He works a maximum of 8 hours per day. What is the range of the function for this situation? So I know we haven't really talked about linear functions yet, so I did give you all the function. I said Y equals 80 plus 45x. So we're talking about the range. So in this case, remember, we're talking about the roid part of our mnemonic, which is the output, okay? Or it's also the Y variable. So we're thinking about what are the possible values of Y. So we can automatically cross off answer choices A and C. So the values of Y, well, let's think about how many hours he works. If he works no hours, we would get Y equals 80 plus 45 times 0, right, for 0 hours. So that equals 80. So 80 would be the smallest value in our range. So that's leading us to answer choice B, but let's verify that 440 is the largest value. The reason is because he can work a maximum of 8. So if we plug in 8, we get 80 plus 45 times 8, which equals 80. 45 times 8 is 360, so that's 80 plus 360, which is in fact 440. So now let's work on what we're going to talk about today. So today's topic is what's in 2.07. So let's describe the domain and range of this function. So this is like the problems you all were working on last week. Remember that domain is the x values. So when we look at this graph, we can see that the domain values that are included are -2, and we're just going to list them out. So we have -2, 1, 2, and 3. The range is the y values, so we can once again list them out. We can see the y values included here are 2. Although 2 is included twice, you don't write it twice. Okay, you only need to write it once. We have 3, and we also have 4. So let's talk about this. So you all told me how you would describe the location of the house with a purple roof. You said you would say it's the corner of 3rd and Main. And then some of you said it's on Main Street between 3rd and 4th. which are all excellent descriptions. Notice that you gave me an X direction and you gave me a Y direction when you described the location of the house, right? You didn't just say it was on Main Street, or you didn't just say it was on 3rd Street. You gave me an X and Y direction, which is how we describe it when we're talking about the location of a function. So that's really what we're doing when we're talking about domain and range. Domain and range are really our way of telling you this is where your function lives on the coordinate plane. Domain is telling you all the X values. Range is telling you all of the Y values. So if we look at this function, I'm going to show you these are the domain and range. Do you see what I did here is I highlighted the Y values that are included in this function, and then I highlighted in yellow the domain values that are included in this function. So that's how you would tell someone where this function is. You would say the domain is between -2 and 2, and the range is between -4 and 4. So basically what you're saying is what part of the x-axis is included in the graph and what part of the y-axis is included in the graph. So to do this, you're going to have to describe parts of graphs as an inequality. So let's imagine this is our x-axis, and we say this part of the x-axis is included in our domain. What you would do is you would say you write the two endpoints. So we have -2 and 4. We're talking about x, so we put x in the middle. So this open circle, remember, this is going to follow our jelly donut rules. If it's an open circle, it's going to be a less than sign. At 4, we have a filled in circle, so you use a less than or equal to sign. And so this is really important. And since we're writing it from lowest to highest, our inequality signs are all going to be less than if we go in that order. So in this problem, let's imagine this is our y-axis. When I go from lowest to highest, I'm going to say -5 to 6. And I'm going to put y in the middle. -5 is going to be included, so we're going to do a less than or equal to. And then 6 is going to be included, so we're going to do a less than or equal to. So don't forget Dixie-Royd. That tells you that domain is x, and then it tells you that range is y. So in Algebra 1, we're going to be studying 3 types of functions. We're going to be studying linear functions, quadratics, and exponential. Linear we're going to study in more detail in Units 3 and 4, and then quadratics and exponential we'll work on next semester. So today's goal is not to go in detail on these functions. We're going to work on describing the domain and range of these functions. So for right now, that's all you need to know is how to describe the domain and range. So let's look at this example. How would you describe the location of this function? So to describe the domain, a good place to start is to draw in boundary lines. I'm going to draw in a line beyond which my function does not exist to the left. Then I'm going to draw in a line beyond which my function does not exist to the right. So if I look at those values, okay, if I look at my x-axis, that goes from -2 to 2. And then I put x in the middle. Remember, if I write in this order, both of my inequality signs will be less than signs. Since I have an open circle at both endpoints, I don't need to include those values. Range is going to be y. So when we talk about range, we go from the lowest value, which is here, to the highest value, which is here. So that means that my range is going to go from -3 to +2. I put y in the middle. At -3, okay, so look, -3 looks a little bit different, right? I don't have a circle there, but I don't have an open circle. So a line that just continues like that is the same as a filled in circle. Okay, so that value of -3 is actually going to get included. It's going to be -3 less than or equal to y. And then at 2, I have an open circle, so that's going to be a less than. So remember, what we're doing here is we're drawing boxes around our given function. You draw a box around your function, and then you use those boxes to determine the x values, which are found on the x-axis, and then you determine the range, which is found on the y-axis. So you draw a box around the function. So an analogy I like to think of is like kind of like if you have a garden that's in a box, that's what you're doing. You're putting a box around your function, and you're saying, this is where my function lives. So now let's try some more problems. Let's do the domain and range of the function in the graph. So I draw this boundary line here. That's the leftmost point, and then I draw a boundary line at my rightmost point. Okay, so domain is going to go from -4 to 1, and I put x in the middle. At -4, I have a filled in circle, so I'm going to use a less than or equal to sign. At 1, I have an open circle, so I use a less than sign. Now for the range. The range is going to go from here at -2 to here at 1. So I go -2 to to 1. I put y in the middle. At negative 2, I have a filled in circle, so I do less than or equal to. At 1, I have an open circle, so I do a less than sign. So now on this problem, let's think about the domain. So here's my left boundary, okay? And then here is my right boundary. So my left boundary goes from negative 2 to my right boundary at 2, and I put x in the middle. At negative 2, I have a filled in circle, so I'm going to write less than or equal to. At 2, I have an open circle, so I write less than. My range is going to be my values of y. So here is my lowest value, and then here is my highest value. So my lowest value in range is negative 4, and I have y in the middle, and then the highest value is 0. So now let's think about what's happening at negative 4. So the filled in circle means it's included, the open circle means it's not included. Well, as long as it's included at least once, I can include it. So it's going to be a less than or equal to. So if you ever have a filled in circle and an open circle together, the filled in circle wins. So it's going to be less than or equal to. At 0, I have that line continuing, so that's going to be less than or equal to. It's going to be included there also. Now about this graph. So if I think about my domain, here's my left boundary, here's my right boundary. So my domain will go from negative 2 to 2. I put x in the middle. I have open circles at both ends, so I'm going to write less than signs. The range is going to go from negative 4 to 4. So I write negative 4, put a y in the middle, and then write 4 at the other end. I have open circles at both ends, so I write less than signs. Now let's try this problem. The domain is going to go from left to right. So I draw in my boundary lines. The leftmost value is at negative 2, the rightmost value is at 2. I put x in the middle. I have open circles at both ends, so I'm going to write less than signs. The range is going to go from negative 3 to 2. So I write negative 3, put y in the middle, and I write 2. At negative 3, I don't have an open circle, I just have a straight line, so that's going to be less than or equal to, and then y is going to be less than, because I have an open circle there.